Welcome to the Intel Network Builders Technology vSummit series. It's time now for our session on secure, scalable multi-cloud SSL orchestration using F5 Big IP and Fortanix with Intel Software Guard extensions, part of the Network Platform Security and Services vSummit. Nearly 90% of all internet traffic is encrypted with SSL TLS. F5 solutions provide SSL orchestration using TLS Encryption, which requires a hardware security module and key management service to execute and protect the cryptographic operations and keys. Fortanix provides the HSM and KMS that use Intel Software Guard extensions to protect encryption keys, secrets and tokens across on-premises data centers and in public cloud. Well, to tell us more, I would like to welcome Faisal Faruqi, who is Principal Engineer and System Architect at Fortanix, and Greg Coward, Solution Architect, Emerging Solutions Business Development at F5. Welcome both of you. Thank you very much for joining us on the session today. Faisal, if I could start by asking a few questions to you. What are the key enabling technologies that allows Fortanix to deliver its platform?
Fortanix uses Intel's Software Guard extension technology extensively to provide a secure environment. And typical servers today, they give you options to secure your data in transit or at rest. But with Intel's Software Guard extension, we are giving you ability to secure your data even in use, while in use. So that's one key technology at the hardware level, which gives us the trusted execution environment. Based on top of that, we also have cloud orchestration and automation technology. Our software is built on modern software stack, leveraging container-based systems, which can run in multi-cloud or on-prem. And we give you a single point of audit of all your events, all your key usage. That makes it easy to monitor how the keys are being used. And also, you have a lot of policy controls that you can set. In addition to that, our entire system is based on modern REST APIs, which the DevOps people really love, and it's easy for them to build applications around it, and they can leverage these APIs to communicate with the KMS.
And how does Intel SGX protect the encryption keys, and how is this different from a typical server?
So a typical server allows you to encrypt your data at rest or in transit. With Intel Software Guard extension, we are able to use their technology to create the trusted execution environment, which allows for data to be protected and encrypted even while in use. And this is groundbreaking technology because while in use, a typical server will always have the data in the memory that can be potentially harvested. And with Intel's SGX technology, you will not be able to go and dump out the data from the memory. Even in use, the data is going to be encrypted. And in our technology, we have these 7 layers of security and protection. At the core of this is obviously Intel SGX. And then on top of that, we have firewalls in the appliance. It is also based on a hardened operating system. And we have a hardened FIPS chassis to give you physical security. And then, of course, you can deploy these in a secure data center. So that allows you to have a very secure system.
And how common is TLS encryption today?
It is very common. So, in fact, as you mentioned, there are 90% of the traffic on the internet is encrypted over TLS. In fact, a common user today will be alarmed if they don't see HTTPS in their browser. So TLS keys are very popular, and all the applications out there on the internet are definitely using TLS. Even on the intranet, when applications talk to each other, you would notice that they tend to use TLS for making sure that the data is encrypted when communicating between the two entities.
So why is it important to store the TLS keys in Fortanix?
First of all, these TLS keys are important. The private key is very important because that's your key to the kingdom, so to speak. And if those TLS keys get compromised, then you can go and start reading the traffic, the data coming into the system. So making sure that the TLS keys cannot be compromised or wrong people cannot get access to it is very important. Secondly, you want to have control. You want to be able to rotate these keys. You want to be able to manage these keys. If these keys are sitting around on all your possible web servers, it becomes extremely hard to take control of them. You do not know how many keys are there, when are they expiring, how are they going to be used, and can I revoke these keys? But if you store these keys in Fortanix, you have a single pane of glass where you can not only control these keys, you can set policies around it.
So as you mentioned, you have a single pane of glass there. What is the advantage of storing the keys in one location outside of the cloud?
You're keeping your keys away from the cloud so that you can be in control. And as I mentioned earlier, that it also allows you to be able to rotate your keys at will. And let's say if the key gets compromised and you want to replace the key, it becomes a lot easier for you. And possibly if you have a multi-cloud environment and if you are running your application across different virtual machines in the same cloud also, and if you want to share these keys, then it becomes much easier if you are storing the keys outside and let your applications come and consume those keys from the KMS, like a Fortanix self-defending KMS.
And Faisal, how is Intel SGX available when running in Azure?
So Azure has confidential computing concept, and in that they launched confidential computing a while ago. In confidential computing, they made a series of virtual machines called DCSV2 series virtual machines. These are Intel SGX enabled. So if you launch a virtual machine of that kind, that virtual machine will give you the Intel SGX.
And can you tell us more about how Fortanix handles multi-tenancy?
Our solution is built ground up for multi-tenancy, and you have this concept of multiple accounts. An account is basically a tenant, and each tenant is cryptographically separated from each other. The data of each tenant is going to be encrypted with a account specific key. And within the account, we have this concept of groups. Groups contain applications or security objects or keys, and groups can be considered as containers where you can also, within an account, you can have separation of groups. And the idea of the groups is that an application in one group can only look at the keys that are in that specific group. So for example, for your use cases, which requires you to separate the keys out, for example, if you have a PKI application and a TLS application, you do not want those keys to be seen by each other. You can put them in different groups. And we have tight RBAC controls, which allows you to make sure that only intended applications or the users can use the keys that they're entitled to.
But can you integrate the login with other security management systems?
The logging is a very important aspect of any key management system, because you want to always know who is using the key. And this is a good security hygiene, that you need to be able to understand and have forensics of who used the key, when, and for what purposes. So we have extensive audit logging today, which allows people to look at the key usage. And not only that, we also allow you to integrate and push these logs into your own SIM systems. For example, we allow you to push these logs via syslog or to a Splunk. That way you can have a centralized place where all your key management logging is stored. And one of the other aspects of our system is that you need to have a key lifecycle. You're not only storing the keys, you're managing the keys. As I mentioned earlier, you want to be able to revoke the key. You want to be able to retire a key, for example, or expire a key. So we support a very extensive set of key lifecycle functions. You can have very fine-grained control. You can have a key lifecycle where you can decide when the key is deactivated, it cannot be used anymore. And you can also set up a key rotation policy to rotate the keys automatically.
And why is performance important in the context of TLS?
So when you connect to a web server that is using TLS, the initial handshake requires a bunch of cryptographic operations like signature generation and verification. And you want to make sure that your web server is able to allow you to connect a lot of applications at the same time concurrently. And if the performance is not there, if it is taking too long to make a connection and do the initial TLS handshake, then that diminishes your server's ability to serve the request. So that's why when we are storing these TLS keys in a KMS system, which is very good because it's going to be a lot more secure, you also want to make sure that your performance is not too negatively impacted. Otherwise, your web server or your application will not be able to serve the request that you wanted to serve. And so that's why it is extremely important that your KMS solution is able to deliver the performance that your web application needs. In our example, as you can see in this slide, we did a before and after kind of a comparison where you have a TLS key sitting on the file system versus a TLS key sitting in Fortanix self-defending KMS. And you will notice that both in a hosted environment in the cloud and also in the on-prem, the performance difference is not too much. The latency is a little bit higher, but the throughput and the request per seconds numbers are very close to what you would see if the TLS keys were sitting on the file system itself.
Thank you very much, Faisal. And if I could turn to you, Greg, why is Fortanix a good fit for SSL TLS key management?
Sure, thank you. It's really pretty much a lot of the stuff Faisal mentioned. There's three major reasons that why F5, works with Fortanix and recommends it highly for our customers. Is the fact that it's cloud agnostic. So as we get our customers, our joint enterprise customers, are becoming more fluent with multi-cloud, with hybrid cloud. They're deploying their workloads everywhere. But one of the things we're concerned about with regards to cloud is vendor lock-ins. So while I can actually deploy, a native cloud key management service or something on premise, having the ability to have something that's completely agnostic to the cloud, in other words, I'm not locked into AWS, I'm not locked into Azure, I can make use of multiple clouds, is really important to our customers. So being cloud agnostic is important. The other one, of course, is being secure, highly available and scalable. And this is where the cloud really shines. And this is really the beauty with Fortanix, is because I get the first part, I get the cloud agnostic, but I get all the benefits of the cloud. In other words, I get to operate at very high capacity. We can scale out quite easily at the Fortanix system in the cloud, and it's also very secure. So making use of the Intel SGX technology, we're able to still have our applications and our keys hosted in this environment, but in a very secure, isolated manner. And then, of course, the last reason would be full control. So once again, when I go back to other systems, I can make use of other systems, but to truly have full control end-to-end of my key management system, I really need to have complete ownership of that. And with the Fortanix system, I get that. And for a lot of enterprises, it's extremely important, if not even just a hard set requirement, that you have to have full control of your key management system. And the nice thing is Fortanix gives us all of this from one platform. Very handy.
Thanks, Greg. And can you explain how the solution works in a multi-cloud environment?
Certainly. And actually, we're going to do a little demo here in a second. But really, this is kind of an example. And as you're seeing on the slide here, this is a pretty classic example, albeit simplified, where we have just that. We have applications that are deployed in multiple clouds. They're deployed on premise. It's the same application, but it's being delivered to its end users where their end users are at. And all too often we see with our enterprises, they're not just using, once again, one single cloud. They're using the cloud that works most effective for them and their endpoint. Once again, it could be on premises. The ability to have our centralized key management system with Fortanix, in this case stored up in Azure for our demonstration, gives me once again that ability to make use of those keys globally. So regardless of where my keys are being stored at, I can keep them consistent, keep them secured. I can manage my rotation and manage the overall key infrastructure centrally, but still provide that value to all my applications across the globe.
So Greg, why don't you talk us through the demo?
Sure, absolutely. So what we're going to do here is we're actually going to deploy the Nginx system and configure it with our big IP. So this is one of our environments. This is our on-premise environment from that previous slide. So the first thing I need to do is I actually need to log into the Fortanix system. So as you can see here, I'm logged into the Fortanix system right now. I've got my dashboard up. You can see I have a security object. I do have an application as well. As Faisal mentioned, these are our storage units. And on my application, I need to grab a couple of things here. So my application to connect to the big IP, and this is basically our door in, I need to copy my UUID. So I'm going to copy my UUID for the application. In addition, I need to grab the API key. So I'm going to copy my API key as well. And with these two pieces of security information, I'm going to be able to actually connect up my big IP to the system. So that's all I really need from the Fortanix to start with. It's already set up. I have my big IP I need to configure. First, let's take a look at actually the application in action here. So I'm going to log into the site here. And as you can see, I get a security warning. And the reason why I'm getting a security warning is because I'm not using a properly formatted certificate. I'm actually using the default certificate for my big IP. So as you can see real quick here. So I basically have my application set up, but I don't have the key system set up correctly. So I'm going to go ahead and log into my big IP. And we'll take a look at that and show you what I'm talking about. So I go to my virtual servers here. This is the big IP interface. And as I scroll down here, you'll see under my SSL profiles here, I have my client SSL. And that's, once again, is just my default certificate on my big IP. So what I need to do is I need to actually get my certificate set up for my application. And to start with, I need to basically configure the Fortanix system. So from the big IP's CLI interface, I basically need to do a couple things here. I need to import the PKCS library from Fortanix. I need to install a partition. This is what I'm doing right now. And then I need to configure the Fortanix system. And this is, once again, I need to provide my UUID that I copied, and I need to provide that API key as well. So once again, what we need is the API key and the UUID. So now that I have that, I can turn my attention to the actual big IP and do the rest of this configuration through the big IP's GUI interface. Now, one thing to note is I can actually do all of this automated. We have our AS3 declarations, in other words, our automated declarative API for configuring the big IP. I can use that as well to basically configure everything you're seeing here in an automated fashion, so part of a CI/CD toolchain, for example. So now back in the big IP here, what I need to do now is take a look at my setup. So I'm going to first go to my external HSM, and I can take a look at what we just configured through the command line. I'm actually have the ability to test this connectivity first. So I'm actually going to do a test to Fortanix. So we're connecting out to it right now, verifying connectivity is working. Everything looks good there. And then I basically need to go to my certificates. And I already have my one certificate installed there as well for my application. But now the way I need to basically install the key. So the way I'm going to do to install the key is, rather than actually installing it, is I'm actually going to point to our external HSM, in this case, Fortanix. So I choose Fortanix, give it a name for my key. This key must match the name of my key in the Fortanix system. I specify its external HCM. I specify my partition, and then I add my key. So now I have my key pointer, and I have my certificate. So now the next thing I need to do is go to my profiles, and I'm going to create a new client SSL profile. This is the profile that's associated with my virtual server. So when people are reaching the application, they're going to hit our virtual server. They're going to get the certificate and key, do the key negotiation. We're off to the races. So I create my profile here. I'm going to specify, once again, my certificate. So I'm going to grab that My App certificate. I'm going to grab that My App key pointer to my external HSM. And that's it. And then I need to go down there, go to the bottom, just click on Finish and Update. And then I have my new SSL profile. I'm going to grab my virtual server. I'll scroll back down to where I specify my profile, and I'm going to replace that client SSL with my App SSL profile. Click Update. And at this point now, my application is now protected with my new certificate and my key. So now any crypto operations are going to be offloaded to Fortanix. So I'll just do a quick refresh. And there you go. You'll notice my key now is correct, secure, and we're ready to go. Pretty straightforward. It really takes about 5-10 minutes to install the system, and you're ready to go. So that's it. As far as the demonstration goes, it's pretty straightforward. All I need to do really is, once again, is configure for the CLI, install my plugin, and configure my certificate in the GUI, and then I'm off to the races. And now my application is being secured centrally by that key management system in Fortanix.
Great. Thank you, Greg, for walking us through that. I wonder, can you tell us some more about the new joint solution that's coming out with Intel?
Yes, absolutely. So this is something that's coming out we're very excited about. So a little background, once again, F5's flagship product, the Big IP platform, traditionally is a hardware product. It provides a host of different services, from just traffic management to DNS to layer 3, layer 4 firewalling, WAF firewalling, access control and management. All this can be offered on the same platform. But as clouds and as enterprises start going more toward native cloud technologies, F5 had to change its way as well. So we do offer our virtual edition. So the virtual edition of the Big IP is basically the same as any of our CU or single U chassis or 8U chassis. It's the same look, feel, functionality, but you really obviously suffer on the speeds and feeds. In other words, the processor and the native goodness that you get out of our hardware is not available to you, obviously, in a virtual machine, until we have this solution coming out now. So this is our DDoS solution where we're actually working with the Intel N3000 SmartNIC. And the beauty of using the SmartNIC technology is it just takes a massive load off of our processors and our Big IP devices. So when you're talking about a volumetric attack like DDoS, you're just getting hammered with attacks. But with the SmartNIC, we're basically able to put that on the edge of our system, and it handles a massive amount of the mitigation for DDoS before the device is even affected. In other words, before our CPU is even utilized, which means our CPU can be used for other things. What this does, though, is it gives us the ability to recognize and realize things like 300 times performance, while actually lowering the cost of ownership on our devices because we don't have to make our devices so huge to handle such a workload. This is something that the SmartNIC gives us in a virtual edition, which is extremely exciting for us. So it's something that's it's fairly new. We're really excited about it, and there'll be more to come.
That's great. Well, Greg and Faisal, thank you both very much indeed for taking part in our session today. And don't forget to watch our other sessions in the Network Platform Security and Services vSummit. We have a session on security for a multi-hybrid cloud environment, plus a further session on cloud-native security, and also one on accelerating secure digital transformation with VMware SD-WAN and Zscaler. For now though, thank you very much for watching and goodbye.